Hey guys, so this week in science, we're talking about energy, specifically energy and how it connects with speed. Now I have a car here. If I wanted to make this car go fast across this table, well, I can push it. Didn't go very fast because I didn't push it very hard. But in class, you would have said, oh, well, you've got to push it harder. So if I push it harder, it's going faster, okay? And it travels longer. So we're going to put some science words with that. If I am to push it harder, I am transferring more energy from my hand to the car. Right now, that car is not working. It's not moving, it's not changing. It potentially could, which we call that it has potential energy, but it's not moving, so it doesn't have kinetic energy. But my hand right now could transfer its energy to this car, making that car start working. Okay, so start changing, start moving. So if I transfer more energy to this car, means I'm going to push it harder, the faster it's going to go. The speed will go faster. That means speed means that going from one point to the other point in a shorter amount of time. So knowing that, let's think about if I was to eat. When you do lunch, if I eat just one little piece of cheese and then expect to go run a marathon, I probably am not going to go that fast because I didn't put enough energy into my body to run fast, to have an output of more energy. But if I eat a really good meal, full of good energy, full of good calories, then I probably am going to be able to run faster. So the more good energy I put in my body, then the more energy I can put out. Now, for this week's lab, you were to design a Twistorama. So I went ahead and made mine. Well, if you were confused on how to fold it, so it looked like this, okay, not cut up, but it was full, and I colored my people two different colors. I folded it in half one way on that thick line, then I folded it again on the thin line, so it looked like this before I cut it. Then I cut the dotted lines to the stop signs on both sides all the way through. Okay, then I fold up, make sure this bar matches. Then I fold that piece down, make sure that bar matches. And I'm going to put a binder clip right here on that bar right there. Okay, and I did 2 of them because we're going to compare them. Always keep in mind our focus today is energy and speed, the connection between energy and speed. Now, this is a ride at a local amusement park, and this ride wants to go fast, because what's the point of an exciting ride if it can't go fast? So we need to have this spin. It's going to spin like this, fast. I want it to spin fast. The things I have is a thick rubber band to have this dangle, to have it hang, and a thin rubber band. Okay, and I cut those rubber bands to where it's one long strip like this. Okay, so it's not a circle anymore, it's one long strip. And I'm going to take my ruler so it can hang off of your table on both sides, because we're going to create 2 of these. Let me get my other 2 heavy books to hold the ruler so the ruler doesn't fall. Now I have my rides able to hang off the edge, and I'm going to attach my rubber band to my Twist-O-Matic, and it looks like this. Okay, do that, and I'm going to attach it to my ruler, just like that. Okay, and I'm going to do that to the other side with the thin rubber band. We're going to see what kind of rubber band would make this a better ride. Remember, there's no point in riding these rides at the fair if they're not fun and exciting and thrilling. Okay, we want it to go fast. Okay, so we kind of try to make it the same and try to make it where it's not leaning one way or the other. Okay, now we're going to make this ride spin kind of like this. One spin is when that man comes back around. So that's a half a spin. It has to come back to the original position. That's one spin. Okay, so that's what we're counting when we say spin. When I rotate it and I twist it, it has to do the same thing. That's one twist. Okay, so we're going to see, first of all, can I make it twist or spin 5 times? So I have my thick rubber band. We're going to try this. I think if I do 5 spins, 5 rotations, then, or 5 twists, then it should spin 5 times. Let's see. 1, 2, 3, 4, 5. Okay, see how it's twisted up? Right now it is not moving. It potentially could, so we call this, it's stored up some potential energy here. Now we're going to count, see how many times we see his face come back to this position, and see how many spins 5 twists gave us. Okay, ready? 1, 2, 3, 4, 5. So it was 5 twists did make 5 spins. So let's see if this is the same thing with this with the thin rubber band. I want to make it into, I want it also to do 5 spins. That means when I let go, that man comes back to this position 5 times. So let's see if it does the same thing as our thick rubber band. We're going to do 5 twists. 1, 2, 3, 4, 5. Now, you notice it's twisted up right there. And yes, that is the bell because I'm at school. All right. It's twisted up. So when I let go, it could potentially spin. So that means it has potential energy. So I'm going to let go of it, and we're going to count how many spins 5 twists in the thin rubber band gives us. So let's see. Oh, it's a lot slower right now. 1, 2, 3, 4. Is it gonna make it? It's going awfully slow. It might. It's going. And it stopped. Now, it didn't quite make it to 5. It almost did. But the biggest difference I noticed was this went faster to get to 5 spins than this one. So I want to make this into 5 spins, okay? So I wonder if I can make this into 5 spins. So I would have to, let's try 6, okay? Ready? 1, 2, 3, 4, 5, 6. 6 twists. Let's see if we can get 5 spins out of that. And I want you to notice, observe the same thing. Will it go faster or slower? Because I gave more twists. notice there's potential energy stored up here, because when I let go, it's going to change. Ready? Let's see. Still kind of slow. 1, 2, 3, 4, 5. Oh, it might be too much. And we're getting to 6. So it's between 5 and 6 twists. But if you notice, it still was slower. The thin rubber band ended up being slower. I wonder why. If I was wanting to go on a ride, I would want the thick rubber band because it would go faster. That's the point of the ride. I wonder why. So let's think about this. If I ate a lot of good food, or if I pushed this car really hard and I transferred more energy to it, then it's going to go faster. It's going to put out more energy, just like our thick rubber band did. This gave more energy faster than this one. So this right here is where the secret is. When I'm twisting it, it feels like it's more work because I can feel it. It takes more work from my hand. It takes more energy out of me to twist a thicker rubber band than the thinner rubber band. So I'm putting more energy into this rubber band. So if I twist it and I transfer more energy in order to twist it, then more energy is going to come out of this paper when it starts spinning, therefore making it faster. So the more energy we put into something, the faster, the speed is going to be greater. Now, this was pretty easy. This was almost felt like I wasn't even twisting it, okay? This required a little bit more work out of me. So, and look how fast it goes. So we can see a connection here. The more energy that something can store up, then the faster it goes. Now let's see. What if I want this to go fast? So I'm going to have to store up more energy into it. So I'm going to have to twist it a whole bunch of times, more than this one, in order for it to go as fast as this one. And as I'm twisting, it kind of, at first I thought this would go faster because it's lighter, but it wasn't the case. Now look how much energy is being stored up. I don't know if you can see it, but it has little twists all around it. So I'm going to try to get as much as I can, see if we can get it to go faster. Look how much energy I'm putting into it. I'm having twisted a whole lot. Okay, so, all right, so it's like, you can't really see it, but it's twisted really, really a whole lot. So way more than I had to do for this one. So let's see how fast it can go. Oh, it's going faster. So I stored up more energy into that thin rubber band in order to create this going faster, just like this rubber band. This rubber band, I can store up more energy easier because it can hold more energy. I have to work a little bit harder. I have to twist it more. I have to give it more energy. This doesn't need as many twists because it can store a lot more in one twist. So when I let go, so the thicker the rubber band, the faster it will go because it can store more energy in here than the thin one. So the concept that you need to remember is the more energy it can store up, the faster it can go when that energy gets converted to kinetic, meaning it can, when it starts actually moving, actually working, and actually changing. Okay? So as you're doing this and looking at this video and working on your science papers, I want you to start thinking, how could we use this in the real world? We have amusement park rides that have a bungee cord. I know, like, they pull you down and then shoot you up, and you can bounce up and down, kind of like this. They do like this, okay? You might not want, it might not be very fun to do little bitty cords, bungee cords. It might be more fun to do thicker ones or bigger ones, because look how much this requires a lot more energy from me to pull down than this one. Okay, so I'm gonna watch. same height that I'm pulling down, and watch what's gonna happen. That one was way cooler than this one. So when you're doing amusement rides, they design it to where it's more thrilling to have something that could store more energy in less time than something that can't store as much energy in the same amount of time, because we want to go faster. So the more energy you can store up, the faster it can go. All right, so that's your science lesson. If you have any questions, or if you want to share your designs, please feel free. You can email it to us. You can post it on your Google Classroom. You can share it in your Google Drive. Or have just your parents send us a picture of it on Facebook. That would be fantastic for everybody to see. All right, guys. We will see you next time. Bye.